Consider the curve given by the equation 6xy equals 2 plus y to the third. Show that dy over dx equals 2y over y squared minus 2x.
So they're pretty much telling us, starting here, I want you to get to this one. So what they're really grading is everything in between, okay? So let's write out the following. On part A, write out 6xy. It's the given information, is equal to 2 plus y cubed. Make sure you're all writing with me. And we are going to derive this implicitly. So derive with respect to x, meaning anything that's not an x. When we derive it, we're going to put dy over dx. So here we go. For this one, let's go ahead and rewrite this as 6x times 1y. So what is the derivative of 6? 6. And then we keep the second one, which is y. Plus I keep the first. And when I derive the y, it is 1, right? 1. And then I need to add on what else? dy over dx is equal to, on the other side, what is the derivative of y cubed?
3y.
3y squared. And then we have dy over dx. So I'm going to go ahead and put all the dy over dx's together. So I'm going to move this guy. And I'm going to move this one. So we have 6x dy over dx is equal to, not equal to, I meant to move the other one, right? Should be minus 3y squared dy over dx is equal to, when I move the 6y over, that becomes minus 6y. Now I'm going to go ahead and factor this out and divide it by the coefficient. And that I'm going to do with one go. So dy over dx is equal to, I already have minus 6y on top. On the bottom is my coefficients, 6x minus 3y squared. And then I need to try to get to what they wanted. So what they wanted was 2y over y squared minus 2x. It doesn't quite look like it, right? So let's kind of think about, what can I divide the 6 and the 3 by? Negative 3. So then I get minus 2y is equal to 2x minus y squared. So we're almost there. So let's compare. My 2y is positive. My y is positive. My 2x is negative. So all I need to do is take everything on the top and the bottom, multiply by what? Negative 1. So my final answer then, we have dy over dx is equal to 2y. And since I want to write it in the same format, y squared minus 2x. And we got to it. If you chose to write out negative 2x plus y squared, it is okay. So our point system. Can you derive 1 point? And everything in between is going to be another point. Because we know the final goal, so they're not going to give you credit for copying the final goal. Okay? So if you think it is potential, put a check next to those 2 points. Okay, ready for the next one? Part B? Okay, Tim, go ahead and read part B.
Find the coordinates of a point on the curve at which the line tangent to the curve is horizontal. Or explain why no such point exists.
Dude, I'm recording. So horizontal tangent means I have a 0 on top and some number on the bottom. So my main focus is my numerator. So let's go ahead and write out the equation, our slope. We have 2y over y squared minus 2x. So we said which part equal to 0, top or the bottom? Top. Let that equal to 0. We don't care about the bottom at all. So I have 2y is equal to 0. So y must be what?
0.
Y must be 0. And I want to plug that into the original equation. And just so that we're writing more than we need, let's write the original equation. So on the original, I know I have the x, but something magical happens. Let's plug it in. The y value of 0. So we have 6x times 0 is equal to 2 plus 0 all squared. If I'm multiplying something by 0, do I care about what the x is?
No.
No. So my left side of 0 is equal to, my right side is what?
2.
2. Is that ever possible?
No.
Never. So let's write never true. So that means we do not have a curve that is horizontal. And I'm going to steal the sentence stem on this one. Always use the sentences that they give you, or you don't have to, but write more than you need. So I'm going to use something like this. I'm going to start with, there is no point. So I'm going to put therefore. You don't have to put the sign. There is no point on the curve at which the line tangent to the curve is horizontal. And there's 2 points hidden in here. Knowing to set the top equal to 0 is 1 point. And then your conclusion with work right in between, that's another point. You have to test it and notice it's never true. So therefore, there's not a horizontal tangent. Okay, go ahead and grade yourself on those. Put a check or an X. All right, part C. The first one was if you derived it implicitly correctly is 1 point, and everything in between is another point, because we know we have to get to that final anyways. Okay, Lauren, let's read part C.
Find the coordinates of the point on the curve that shows the line tangent to the curve is vertical, or explain why no such point.
Vertical. So we have a vertical line. For the vertical line, it means we're dividing by what? 0. So that's our focus right here. So B and C kind of goes together, but it's still considered independent. So let's write out our equation. We have 2y over y squared minus 2x. And the bottom this time is equal to 0 to make it undefined. So we have y squared minus 2x is equal to 0. And for this one, let's go ahead and solve for x. To solve for x, I know I have to subtract y squared over negative 2. That's going to give us y squared over 2. And I know we have 2 different variables, which is fine because we have really in the end 2 equations. Let's plug this guy in place of this x. What was it? Plus y cubed. So when I plug it in, we get 6 times y squared over 2 times the y is equal to 2 plus y cubed. So now we have 1 variable, so we can solve for it. So let's think about simplifying. What is 6 divided by 2? 3. And I have y squared times another y. That will be y to the what? Cubed. And on the other side, we have 2 plus y cubed. And then I'm going to subtract y cubed on both sides. When I do, how many do I have on the left? 2y cubed is equal to 2. So my y must be 1. So let's go ahead and put, it does exist. And this is our x comma y. I found the y value. So now I can find the x value by plugging it in here. So we have 6x times a 1 is equal to 2 plus 1 cubed, which technically we have 6x. How many is on the right side? 3. So we know our x must be 1/2. So this one does exist. So I'm going to write out the tangent line to the curve is vertical at half, comma 1. And there's actually 3 points hidden on this one. Okay, knowing to set the bottom equal to 0 is 1 point. And all the work in between to find the y value is another point. And our final conclusion is another point. Okay, go ahead and grade yourself. Did you understand? Did you process? So put a check or an X. And now I'm ready for the last one.
We should do this on the AP test too.
I go over it.
Yeah, you should.
We'll copy.
Yeah, we'll copy.
I'll set this up.
Uh-huh.
Have like a mic.
Yeah, yeah.
Okay.
Make sure to talk us through it.
Just let me know which room you're gonna end up in.
Okay.
Okay, just email me.
Oh, you know.
No way. Okay, part D. Holland, let's read the last one.
Particle is moving along the curve at the instant when the particle is at the point 1/2 -2. Its horizontal position is increasing at a rate of dx dt equals 2/3 unit per second. What is the value of dy over dt, the rate of change of the particle's vertical position at that instant?
So we're looking for dy over dt. I'm gonna show you traditionally and then give you a trick behind this. I know we did go over this trick last semester, I think once or twice, but it's been a while. So make sure you know all these facts because I'm not gonna go back to this page. All right, did we already derive a while ago? 6.
Oh, we forgot to derive.
Oh.
No.
Okay. What's that?
They gave it to us in part.
They gave us to us on part A? Okay.
Yeah, we did.
So let's write on here, we have, I might be repeating myself. If I am, that's okay. That's my equation. This time we are deriving with respect to t. So we'll actually need to derive it again. This time it's with respect to t. Ooh, there you go. So again, just like usual, I'm gonna write out 6x times 1y, just for teaching purpose. Okay, when I derive 6x, we get what? 6, and again, this is with respect to t, so I have to say dx over dt. That's the only difference between this one and part A. And then we have times a y, plus, I keep the first one, 6x. Derivative of 1y is 1, but I need to add dy over what? dt. And then on the right, we have 3y squared dy over dt. So from there, let's see what parts I can plug in. And let's also write somewhere on the right, as a reminder, they gave us this point. So anywhere I see an x, I'm going to plug this one in and this one in. And they also gave us dx over dt. Was it 2/3? 2/3? So I can plug in dx over dt here. I can plug in the y, plug in the x, plug in the y. Yep. So we have 6 times 2/3. What was the y value? -2. Plus 6 times, what was the x value? 1/2. And then we have dy over dt. Then we have 3, y was -2 all squared, parentheses is a key here, dy over dt. So let's start simplifying here. So from the left side, what is 6 divided by 3? 2. What is 2 times -4? -8. And then half of 6 is how many? So we have plus 3 dy over dt. And then the other side, that's going to give us positive 4 times 3, which is 12 dy over dt. So then when I move the 3 dy over dt over, I really in the end get 8 is equal to 9 dy over dt, and we're almost there. So we know our dy over dt is equal to negative what? negative 8 over 9. And that is units per seconds. And I did not leave enough room for the trick. Okay, I'm gonna try to write really small. Can y'all like box off this amount?
Yeah.
I'm gonna actually use my whiteout. There's a trick behind this, if you remember, and it's actually faster. But if you choose to solve it traditionally, it's fine too. Okay. Okay, let's do our point system first. For my point, it's gonna go from, did you derive it with respect to t? 1 point. And then our final answer is gonna give you another point. Okay, if you choose not to write the shortcut, that is okay, all right? But if you write it, it might be beneficial. So we know, according to our rules of fractions, we have dy over dt is equal to dy over dx times dx over dt. Let's see the logic behind this. So on the right side, do you see dx and dx on the top and the bottom? If I eliminate this, don't I really get dy over dt? So if you see that, that relationship, you're pretty much good to go, because we know dy over dx, that was given to us. We also know dx over dt, which is 2/3. So let's plug it in. This one involves less work. So we have dy over dt, which is our goal. That's a t. So dy over dt was our fractional value given 2y over y squared minus 2x times 2/3. And then at this point, all I need to do is kind of plug in the values. Let's plug in our values. We know the y, we know the x's. So here I have 2 times negative 2 over negative 2 all squared minus 2 times 1/2 times 2/3. So let's do our math. And I'm going to go straight across the top. What is 2 times negative 2 times positive 2? Negative what? Negative 8? Ooh, we're kind of there, huh? So we're hoping the bottom is going to be 9. So here I go. That's going to give us 4, correct? What is 4 minus 1? And what is 3 times 3? 9. But technically that was all just parentheses, if that helps you. So if you see it that way, cool. The way I would guess that the AP testers will grade is knowing this proportional relationship is 1 point, and then knowing to plug in the value will be another point. And that might also include our final answer too. Again, because it is free response, could I stop right here? Once you plug it in, that's all we need. Okay, go ahead and grade yourself and put how many